Just some recent events and upcoming events. We surpassed 2,000 members this past week.
I think I'm still sharing my screen. So if you're showing something,
that's okay.
on your
I'm not sharing anything. And this is only the work of Erik Svendsen that has made it this far. So I'm happy to take over and see if I can do just as well. But this is a really nice base for a Power BI user group to have 2,000 members. That's an amazing number.
Impressive. Congratulations.
Have you presented here before, Markus?
I don't think so.
Okay.
I'm not sure, but I don't think so.
So
I can't remember that Erik was a host for me.
Oh, I can thank you later.
Mm-hmm.
But obviously it's also about the speakers attending, and we're happy to have you here today, Markus. A couple of upcoming events is obviously the Power BI Next Step in September, and also in September is the Data Insight Summit if you're in the US. So there are 2 events in September, almost coinciding in the middle of September. If you're either in Europe, it's the Power BI Next Step event that you want to go to, and if you're in US, it's the Data Insight Summit in Chicago.
So Power BI Next Step is already sold out. So if you don't have a ticket, now it's too late.
Ah, okay. So and there are no user groups raffling away tickets. I don't have any, but maybe you just have. I don't know.
Mm-hmm, mm-hmm.
Okay. Well, over to you, Markus. You've been in data for ages, and you've run the Austrian SQL PASS, SQL Saturdays, SQL Days, various number of event types down there, and is currently also running a Power BI user group there.
Mm-hmm.
And
all in one. Austria's not that big, and not that many people who got engaged in user groups.
No,
so that's the reason why we do all the same in one user group.
And you have a long track of speaking at various events, SQL Saturday also here in Denmark, and SQLBits and SQL PASS Summit in Seattle, and so on. So we're up for a veteran speaker coming on in just a second. So you will be presenting on how to model your data like a star, and
exactly.
Obviously for the quick, there's a pun in that title. Do you want to elaborate on that, or is that something that you will disclose later on in your talk?
No, the pun is in the end, and so everything is in the title. So this talk is about how you can be a star in modeling your data, but of course also your data model should look like a star schema. So that's the 2 things together in one title. And I'm always happy if people discover that there's a pun intended, because they show that they know something about star schema, which is really, really important.
Yes. Otherwise, we will get to know a star schema during the next hour.
Exactly.
I guess.
Exactly.
Okay, that's enough on my side. I will leave the mic entirely to you, Markus. So please take it away.
Yeah, mange tak, Jens. So I take over here. Model your data like a star. Unintended. Just explained how this title came here. And my name is Markus. As you can see from from my last name, Jensen. This is an original Danish Jensen. My wife is from Denmark, and I took over like her name as the second part of my name. And the most important part about me is I'm Markus, and I can click the next slide. I work with models. And if I explain to people that I work with models, they have sometimes in mind that I work with beautiful people. But instead, I work usually with beautiful data, or data who should be beautified, or is then beautified if I'm finished with the work, hopefully. So we're talking about data models here. Every time I talk about a model, I'm talking about data models. And when we think about Power BI Desktop, because I will concentrate on Power BI Desktop here, but most of the things I assume everything I talk today is also valid for analysis services Tabular or Azure Analysis Services. If we think about Power BI Desktop, Power BI Desktop was born as a self-service BI tool. So before there was Power BI Desktop, there was this Excel add-in Power Pivot, which is still on there, which is still used by many people. But the goal of the whole tool was self-service. So people not formally trained into IT should be able to work with the tool and get their insights, can mesh up their data, build the reports, things like that. Yeah, if there's any questions, please, use the chat window or interrupt me. If it's possible for you to turn on your mic, I'm also fine with you. Just interrupt me and ask questions.
It is not.
It is not. Okay. So then use the chat window. Okay. So, and what's also important with Power BI Desktop, as opposed to other tools, Power BI Desktop is a model-driven tool. So you build a data model. If you want or do not want to, if you just load data, connect to your data, Power BI will build a model for you. It does some educated guesses, and those guesses might be right, they might be wrong, they might be just suboptimal. So it's very important if you take your job or your work or your reports and the numbers you're reporting on serious, then you should also take the modeling thing serious. So other tools which are not model driven, for example, reporting services. If you ever worked with Report Builder, this is not model driven. What you do in Report Builder is that you have to stick together a SQL statement or a DAX IMDX statement or whatever, and then this statement returns a table, like a query result, which is just one table. So in Report Builder, you aim for having like a wide table, and then you build a report on that and pick those columns you want to need. Power BI Desktop is not that tool. So you should not just load a wide table into Power BI Desktop, but build a model. So in most cases this works, but sometimes this doesn't work. So that's why it's so important to talk about the model. So I think data modeling is the most underestimated part and task when working with Power BI Desktop. So the agenda is slim. So we talk about relationships. Again, we talk about relationships in your table, not about your private relationships. We can talk about that after if you want to or need to. We talk about this term denormalizing, which I don't really like. I mean, denormalizing is like turn around the term normalizing, which I do not like either, but it is an industry standard term, so we have to think about what it means and what it's behind. So the concept behind is very important. It's not that I like the concepts behind, but I don't like the term is very well chosen. And then I will pick one dimension to show you some things you mostly will also have to do in your data models, because you have to work with dimensions. We will hear about what the dimensions are. And most probably in your data model, you will have something connected to date or time. That's why the date or time dimension is very crucial to every model. Let's start with relationships. If you talk about relationships, if you open up the model view in Power BI Desktop, then you will see like the tables, and the tables are then connected with lines. And this looks like foreign key constraints. So if you have ever heard about databases, if you ever had attended a course about databases or IT-related things, you most probably heard about databases, and then you heard about tables and relationships there. And relationships have foreign key relationships. Like in the sales table, I have a foreign key, the customer key, which is pointing to a row in the customer table where it identifies exactly one customer there. So this is the foreign key. And the foreign key in the database, in the relational database, make sure that I do not insert a row in my sales table with a customer key which is not existing in the customer table. That's what the foreign key constraint does. The constraint limits the possibilities what I can do in my database, therefore increasing the data quality. In Power BI, there's no constraint. So if you can load two tables, for example, you can load a sales table with customer keys which are not there in the customer table. You can do that. So Power BI doesn't care about that. But what it uses this information for is the other way around. So if I put a filter on my customer table, so for example, I filter on all the customers in Denmark, then it will make sure if there's a filter a relationship there. It will make sure that if I then look at the sales table, for example, summing up the sales amount or counting the orders or whatever, is limited to only those rows which are connected to customers in Denmark. So it's a filter propagation. It's nothing, it's not limiting you anything. It's just doing about filters. And filters are very important, right? Because if you do reports, you do not want to show you like the sales amount for all the years for all the products, but we constantly have either the filter pane or slicers, or even filters, of course, in the visual, because I want to build a column chart per product category, for example. So then on the axis I have my filters then, which I applied to my data. So filters are very important, and this is what the relationships are about. There's two important things with the relationships. One is the filter direction. So the default or the standard thing is and should be a single directed filter. That means if I put a filter on my customer table, for example, on this certain customer, or like customers from Denmark, then the filter will propagate to the sales table, but it will not propagate the other way around. So if I put a filter on the sales table, for example, on the year, I only want to see something from a certain year, this filter will not be applied on the customer table. So if I have two slicers, one on the years, one on my customers' countries, and I select, for example, 1 year, and then I look at the slicer for the customer, I still see all the customers, even customers which did not buy something in the year selected in the year slicer. I could do that by applying bidirectional filters, so that the filter is then going from the year, from the date table to my sales table, and then filtering on sales only from certain years, and therefore also filtering on certain customer keys, which is then filtering the customer table again. But please, please, please do not do that, because this makes your model slow. It makes it maybe ambiguous, and you will have certain situations where you cannot add another dimension, again applying the bidirectional filter. So at this point you would have to change your logic anyways. So please, please, please stay away from bidirectional filters unless in really, really certain use cases. As today we talk about like the introduction level, we're not coming to those use cases, but there's plenty of use cases. But before you introduce the bidirectional filter, please think about, is this really one of those special use cases where we have to use the bidirectional filter? This filter propagation or cascading filters or whatever it's called is not a use case for that. There's other solutions. You could build like, you add a filter on those slicers on the sales table to limit the filter, because bidirectional filters make your model more complicated. The performance will suffer from that. And just to have those slicers influencing each other is not reason enough to make your model complicated. So it's like using a huge hammer on like on a screw. Use the screw and not the hammer. And doing something in the model is usually the hammer, the big hammer. The second thing we have to think about relationships is the cardinality. Again, it's a term. English is my second language. In German language, it would be Kardinalität. I think something similar in Danish. I'm not sure if English is a first language, if cardinality is a term which like makes up a picture immediately if you're not into IT and relationships in tables. But the cardinality is about like numbers. How many rows do I have in one table, and how many, or like the other way around. You pick one row in the sales table and then think about how many rows you will find in the customer table, for example. So for one row in the sales table, I know this is assigned to one single certain customer. So the relationship from the sales table to the customer table is a 1 on the customer table. So if we'll find exactly one row in the customer table. On the other way around, if I pick one arbitrary random customer, there might be that there's no sales at the moment because like the customer is quite new. He or she did not buy anything yet, or there's just the first order. But there's also a chance that this customer I find many rows in the sales table. So this cardinality would be a 1 to many, because for one customer I can't find many sales rows potentially, but for one sale I can only find one single row in the customer table. And again, the 1 to many relationship is the goal for relationships. Stay away from 1 to 1 and many to many relationships. The 1 to 1 relationship means that there's one row here and one row here. If this is the case, I would try to model this as one single table. There might be situations where you do not want to do that. For example, if there's different data sources and you want to schedule the refreshes on different schedules, then you might go for the one-to-one table. But usually you try to have this in one table. And the many-to-many relationship, again, there is certain use cases where we have to use the many-to-many relationship, but if you start your model, maybe you will immediately face the many-to-many problem. So try to again to stay away from the many-to-many relationship. Again, this might make your model slower, and it might make it more complicated. It might also be that there's a data quality issue. So if I connect, if my sales table and if my customer table, and I connect those two, and Power BI is suggesting a many-to-many relationship here, that I know that there's something wrong. There's something wrong in the data, because I know by heart that for one sale, there can be only one customer assigned. And if Power BI does not allow me to do that, that means that one of the rules to have one-to-many relationship is violated. And one of the rules would be that on the one side, the customer key has to be distinct, a unique key. So maybe if you have a data quality issue, there might be, maybe it's just one row, one customer appears 2 times in this table with the same customer key, maybe different names, because some insert update statement went wrong, something went wrong in your source system, then you have the same customer. And if it's just one single row, then Power BI will not allow you to do that. So please watch out if many-to-many is suggested, that maybe you have a data quality issue, or you have to try to find solutions here again. Again, this is not part of this introduction talk. There's different solutions here. You could introduce a bridge table. That's the thing I prefer. You could stay with the many-to-many if it's really a true many-to-many relationship, like one customer could have more than one account. So in a bank account, if you think about, I could owe many bank accounts, and many people could also have the ownership of one single bank account. This would be a classical many-to-many relationship. You could stay with the many-to-many, you could have a bridge table in between, or you could stay away from relationships anyways and use 3Ds, because then with 3Ds in your DAX statement, in your measures, you could come up with a relationship on the fly. Again, 3Ds comes with a performance penalty. So maybe your queries will be reports will be slower. And you want to have slow reports. So try to model everything as single, cross-filter direction, and one-to-many relationship. And one-to-many, of course, always includes the 0 and the 1 also, because there could be like one customer not having a sales amount here. So it's about what's the maximum rows I could expect. That's what we're talking about here. Let's see about the relationships. So what I have here is a Power BI report, a really, really simple model. We can see that there's like 4 accounts in the account table, and there's several transactions, and we have this one-to-many relationship with a single directed filter. So this triangle gives us the hint that there's a filter direction in one direction, because the flat, there's only one flat side and one pointy side, and it points from the account to the transaction. So the filter is going from the account table to the transaction table, but not the other way around. And we also see this is a one-to-many relationship. So there's the account ID is identifying all the accounts and also referring then maybe potentially more than one account ID or more than one row in the transaction table here. Of course, this is a report. This is not a model view. I just thought about making it simple to also see not only the relationships, but also see the actual data. So this is for educational purposes only. And if I click here, I can see that like if I click on bill, then the transactions are limited to only the accounts ID from bill. So this works well. And if I click on the other side, it's not filtering the account table because the filter is not going to the other side. That's the simple part. The harder part is if I click here on the transactions, then you can see there's something happening up in my report, right? So I have this table here where something is filtered to Bill or to Jeff or whoever suddenly there. And the reason for that is that Power BI tries to make it really simple to apply, but sometimes it's hard to understand what's happening here. And the thing is, yes, in my model, there is no filter in between. So one-to-many, there's only one filter between, and this is a single directed filter on the account ID. But there's also something called a cross filter on visuals. So the visuals also put filters on each other. That's the default behavior, which is really useful in many use cases, but it's confusing here because if I click in here and apply a filter on the account ID, and also applies it on my chart up there, on my table there. But this has nothing to do with the model. It's something added in the visual. Something this makes it hard to understand things. For the one-to-one example, I could have a customer table and a customer detail table. Again, as both sides are one size and the filter is only always going from the one side to the other side, this is now a bidirected filter and they cannot change it. So one-to-one relationships are always bidirectional. And I can set a filter on this table and it filters the other one and also the other way around. So filters work in both directions. And then there could be different forms of where one or many is involved. For example, again, our example with the transactions and accounts, so customers or like bank accounts here, and then I have a relationship to my customers here. And again, we see like this the one-to-many relationship single directed from the account to the transaction. This is the same as we just have seen. And then I add another table here, and we can see there's another one-to-many relationship, again with a single directed filter from the account to the account customer. So it means if I select something on the account table, Power BI, DAX, Vertipack, whatever, will make sure that the transaction table and the account customer table are filtered according to the account ID I selected here. But if I filter an account transaction here, it does not filter the account table, and this is not filtering the account table, it will also not filter the account customer. The same is true on the account customer table. So if I filter something here, the filter is not propagated to the account table, and therefore it's not propagated to the transaction table as well. This is important to understand. Yeah. If there's any questions, please, mark your questions with prefix Q, and then I can pick up your questions. I don't change save any changes here. I don't need the rest, and we go back to the slides. The next thing is denormalizing. Before we can talk about denormalizing, we have to talk about normalizing. And I already explained that I don't like the term. Normalizing as a term was invented by Edgar F. Cott, who also happens to be the inventor of relational databases. I'm really grateful. He had this splendid idea back in 1970. So relational databases are quite old, even older than me. And for that, it's very important to normalize data. But let's see what does it mean. So first start with the naive way. So if you say, Markus, please give me a list with all the products, their subcategories and categories, and with all their sales, I would provide you with probably an Excel spreadsheet, right? Because like showing data or transferring data with Excel is nice, but it's not a BI tool. That's the important part here. So I will provide you with an Excel spreadsheet with 4 columns, right? With the product name, the subcategories, the categories, and the sales amount per product. And this is like easy to understand, easy to read, but the problem we are facing with a single table is that we have redundant information. Because if there's one product category which has more than one product, that means the product category name appears several times on this list. And this is not so good in terms of it might use more space, but of course there's compression, so it might not be hard. But we also have this potential for anomalies. So if I want to change something, so I want to change the name of a product category, I have to make sure that I change every single accordance of this category name. If not, if I miss 1 or 2 rows, I end up with still in the real life one category, but it appears under 2 different names in my database. So I have 2 different entities there, which is not good. On the other hand, if I create a new product category, and I don't have any subcategory or product yet there, how would I introduce it to this table? So do I leave them blank, the product category, the product subcategory and product name row? And also the other way around, if I delete a product out of my database, and it happens to be this was the last product which was assigned to a certain product category, if I not take care of that, I would also delete the product category, which I maybe do not want to. So there's a lot of things happening with this redundancy, and that's the reason why application databases don't store the data in a single table, but in a normalized schema. And I see that there's some questions appearing there. I'm interested in how you modify an existing model, accessing extent of change, now new dimension, new attributes. How you modify an existing model, accessing extent of change, new dimensions. I'm not sure if as long as you have access to value, you can add new dimension. Yeah, that's right. I totally agree with Jens' answer. So adding things is not hard. The hard thing is, and that's why I think modeling is so important, because Power BI is really flexible. So you can load any data model. You can load a single table. You can load a fully normalized schema into Power BI, and Power BI will work. So you can build up your reports, and everything is fine, as long as your model, that means the content of your data, is not very big. Depending on the complexity of the model, even with like a with not many rows, you might already face performance issues, but for sure, the bigger the content of the tables gets, the more rows you get in your tables, the more problem you will face performance-wise. And there might be a point in time where you discover that you have really a performance issue, but it's too late to change your model because the model and your reports work hand in hand. If you change your model, so if you like denormalize one of the tables, so you remove one of the tables and put the content in the other table, or you split up tables and remove attributes from one table and move it in another table, it will for sure break your reports. And that's why it's so important to make it right from the beginning. The later you discover those problems, the harder it will be to fix them. So adding new things, no problem at all. Changing existing things, really huge problem. That's why it's important to make it right from the beginning. So what Edgar have got, so please, Asaro, let me know if this answers your question. So the normalized schema is what Edgar have got and introduced. He says, we want to reduce this redundancy. So what you would do is then split up this single table, I just used as an example, into 4 tables. So you would have one table containing the sales amount and the reference to the product. Could be the product name, could be a key ID, whatever. And then you would have a separate table with all the products, with the key or not, and the name of the product, and a reference to the product subcategory. And then you would have a subcategory table with the same thing, an identifier for the subcategory, at least the name, and a reference to the product category. And then you would have the product category table. So the model is now much more complicated, much more tables to do. We don't have any redundancy, and depending on like 3NF stands for third normal form. That's what we so this is like in different steps. There's first, second, and third normal form. It's important to have your model in third normal form if you really want a redundancy. And there's certain use cases you can then fix with this boycott normal form. So again, this is Mr. Cott, the inventor of everything. And there's also academic approaches with fourth, fifth, and even sixth normal form, I guess. But it's really academic in most cases. So you're fine with third normal form. But the problem with third normal form, as it solves all the issues your application might have with inserting, updating things, it is really hard to understand the model, because now I present you with 4 different spreadsheets, like 4 different files, or at least 4 different worksheets in one table, and then you have to connect those things either on your own, or you would write a VLOOKUP or have to write joins in a database to join the tables again. So from the sales table, joining to the product table, joining to the product subcategory and the category table. And then you end up with a long query with joins there. So you have to write the joins right. You have to use the join predicate right. So there's lots of possibilities for errors. And on the other hand, it's also more hard to do for the database, because also the database, SQL Server, Oracle, whatever, they have then to look up those different contents on different places on the disk because it's spread on different tables. So the querying is much harder to write, and it's much harder for the database to do, so it's slower. So that's why a normal schema is not so good for reports, because we would tend to entertain and educate people how to query the stuff there. It's hard to understand. So there's something in between. So denormalizing does not mean to jump back from a normalized schema to one single table. Please don't do that. There's a question. Are the reference books on blocks? Yeah. There's a lot of. I mean, look up. Edgar, I can write like the name of the guy. So Edgar F. I don't know what the second name is. F. Cott on 19. You will find a book about. Is it called? Relational database. I write it in lower cases because I'm not sure what's the exact title. I can look this up for you. So that's the inventor. And if you take any book on data modeling, you will learn about those normal forms. Again, it's only important, the normal forms are only important for you if you're building databases for applications. If you build databases for reporting, business intelligence, analytics, Power BI, analysis services, then please stay away from a third normal form. It's not so important that you understand the third normal form. It's much more important to understand the denormalized schema. And the term denormalized schema was coined by Mr. Ralph Kimball. So there's Mr. Ralph Kimball. If you never heard about him, look up his books. He's now retired. So I think in 2013 he published his third edition of all his books and everything, and then disappeared. So I hope he's healthy and is enjoying his retirement. So he's not active on any conferences. Don't write any articles anymore. That's the one guy. Then there's the other guy, Bill Inman, which is the second godfather of data warehousing. And it's really, really funny to read the articles and read the books because they were not friends. They were really teasing them other and each other, and writing like what the other guy wrote is really rubbish because you have to do it like this. Okay, yeah, thank you very much, Jens, for having you as an assistant here. Yes, the Kimball, the Data Warehouse Toolkit. Exactly, that's the book. That's a must-have. You should read the book. At least that the first portion of the book is very, very, very important. And it's so important for Power BI, not because the denormalized schema is so much better than everything. It's not because Kimball was so much right or more intelligent than Inman or all the other approaches like Data Vault and so on. They're all valid approaches. The only thing why it's so important to understand what Kimball talked about and to understand the denormalized schema is because Power BI and Analysis Service Tabular is optimized for a denormalized schema. So in other tools, in a relational databases, you might have a better performance or easier to build model with other approaches, but Power BI is optimized for a denormalized schema. That's why you will fail with many-to-many relationship, and not fail, but it will be less performant, or your DAX will be more complicated if you don't stick to those things. Avoid many-to-many relationship, avoid bidirectional filters, avoid a header position or header detail approach, avoid other things. Stick to star schema, and writing DAX is much more convenient, and using the model for your end users is also much more convenient. That's the only reason. It's not because this stuff is so much better. I don't think so, because if the tool would be optimized for a different thing, maybe the star schema would not be so fast than in Power BI. So again, denormalized schema invented by Ralph Kimball. So he coined this term, and I learned it also this way. Like I learned first normalizing schemas, and then I heard about denormalizing schema. But I can remember that I'm not sure where I read it, in which of the books or articles of Ralph Kimball. But he writes that like this denormalized schema with facts and dimensions, he already applied in the 60s. So way before the normalized schema was invented, there was already a star schema or sort of star schema, or the concepts were there. What he just did is he produced those books, made it, published it. I think he used it also in the real world. So he did a lot of data warehouse projects, and he coined these terms. So in the denormalized schema, we are reintroducing some redundancy. We are not jumping to the single table, as you might maybe guess from normalized, denormalized. It's not undoing all of the efforts. So it's important to distinguish between fact and dimension tables, because dimension tables, they are fully denormalized. So the fact tables, the dimension tables should not have relationships to other tables anymore. They have all the information in the table. So if I think about a product table, everything about the product, the name, the category name, the subcategory name, the list price, everything you can associate with the product is in the product table, denormalized. So we're having redundancy in there. The facts, on the other hand, we do not denormalize. So we will not have a sales table where I have then the product name and the category name and the subcategory name and the list price in there. That's what you should avoid. And the reason is that the fact table are really huge tables normally compared to the dimension tables. So every byte I add to a fact table adds up a lot of bytes to my whole model, to my whole database. So we try to have them slim, make slim fact tables and have wide dimension tables. So in the dimension table, I'm not discussing anything. Somebody asked me, please add like this word, year, month, name combination to the date table. I'm happy to do that because it's like not even 400 rows in the date dimension. So if I add something there, it's not really increasing the size of my whole database or model. And then we can talk about the star and snowflake schema. So first, jumping to the next on my slides. I'm writing. Yeah, that's a single table. Single table, really, really white. I mean, this doesn't show it white because this is column names. The columns names are displayed under each other. So every attribute I would possibly use in a report, I would contain in one single table. Avoid this. Don't do that. The star snowflake schema means that I have to distinguish between dimensions. So what's dimensions? Those are the tables we make white. They answer questions like how, what, when, where, who, why something happened. So this could be the product, it could be a customer, this could be the date, time, whatever thing you want to filter or group on. So if you put something into a slicer, already know people will filter on that, most probably it will be a dimension. Or you want to show like a column chart or a bar chart or something where you put things on the axis, or a matrix, a pivot table where we put things on the rows or in the columns. Those are things which should be modeled as dimensions. Relatively small is also always relative, right? I worked for a company where we had end users as customers. So when I left the company there, at the end, we had 200 million rows in the customer table, which is not a small table, right? But compared to the fact table, it was still relative to the fact table, it was still small. The dimension table is only always on the one side because it should have a unique identifier and then reference the fact tables reference then the one row from the dimension. And usually a dimension contains a primary key. So that in the relational world, there should be a surrogate key, like an identifier, a number which is just numbering, starting at 1 and just numbering through it. In Power BI, or even analysis services, it's not that hard. You could also use a string, like the product name or the customer name. If very important, it has to be unique and it should not change, because if you change the key, that means that you also have to change all the places where the key was referenced. So that's the only thing here. And then you have columns of all types. So this could be long text, this could be dates, this could be everything in the dimension. Everything is allowed. On the effects, I think the most important thing, this could be transactions, details, measurements, but I think that's what I think is really important. The facts are real world events. So if something happenings in the real world, so think about the supermarket when you do your weekly or daily you buy your daily stuff, then every time it makes beep at the cashier, this is a real world event, and this is something tracked in a fact table at the supermarket. So they know now what product for which price at which cashier in which territory, and if you have a customer card, also with which customer appeared, and then we can do analytics on that. That's the meat of the model. That means we count on things. So we want to know how often or how many customers or how many events were happening on a certain day or in a certain time frame, or for how often did we sell a certain product, and aggregate things like how much sales amount or how much revenue we get up from selling this product. They're relatively big. Also think about the relation, right? This on the many sides. So that means if I have 100 customers and every customer buys 10 products on average, and I have 10 times 100, 10,000 rows in my fact table. So that's why the fact table is always big. And that's why we are really greedy on the fact tables. The fact table should be slim. As it's so big, so long, in terms of long, we should make it slim in terms of be really greedy with the amount of columns, and also be greedy with the data types. So make only foreign keys which are really slim to the dimension table. Because if I have a foreign key which is 1 byte smaller and I have 1 billion rows, this means that's 1 gigabyte of data, right? Which I can save or add. And for star schema and snowflake schema, star schema means really that we have one fact table in the middle, and that's where the names comes from, with a bit of fantasy. We can see like this is a 3-pointed star, more a triangle. I know again. So star schema again, a term Kimball invented. I believe. I'm not really too much happy about the term itself. I'm very happy about the concept, but why is this a star? I mean, it doesn't look like a star. So we have the fact table in the middle and then the dimension table around there. Of course, in the real world model, I would omit the dim. I would introduce blanks in here. So this is just an education example. So this should be this should be reseller sales and not fact reseller sales large. Doesn't make anything here. Any sense here? And as you can see, the dimension tables are only on the one side, and the fact table is always on the many side. And the filter is only going from the dimensions to the facts. That's what we should go for. A snowflake schema would mean that I did not fully denormalize the product table. So maybe if you know AdventureWorks, the sales territory table is already denormalized. So there's the group and region and country, I think, in there. That's the names of the columns, already denormalized in one table. For the product in this example, this is still normalized. And if it's still normalized, it's called a snowflake schema, because like the tips of the star are still split out, and this forms like a snowflake. Yeah. Again, with a lot of fantasy, we could see a snowflake here. That's the term here. And the snowflake schema has disadvantages. So it's make it more harder for the users to know where they find the attributes. If they're looking for something, they have to remember, is this attribute in the product, in the subcategory, in the category table or folder in the UI? And also querying is slow, of course, because if I put a filter on the category and then filters first the subcategory, then filters the product, and then filters the facts. So there's a lot of disadvantages. That's why you should avoid snowflake schema as much as possible. Again, go for the star schema. So if you compare them, they also take longer to load because it's more tables to load. Oh, okay, in 2015, not 2013. Thank you very much, Martin, for pointing out that he closed his doors in this end of 2015. Yeah, filtering is slow because the filter has to be transitioned between different tables. It makes the field pane less intuitive because I have different positions where I find attributes about, for example, the product. And if you want to build hierarchies, which is convenient to use, you cannot build a hierarchy on attributes in different tables or columns in different tables. You have to put them in one table anyway. So that's the reason. Or the back advantage is the backdrafts of Snowflake compared to the star schema. I just did a little example. So this is, your mileage may vary, but I just built a real Power BI model with exactly those attributes which I just have seen, with a single table, all the columns in the table in one single table, the star schema, the Snowflake schema with the product in one table or in 3 tables. And what really came as a surprise to me is that the single table approach is much bigger, already 3-fold bigger than the star schema and the Snowflake schema. So even everything is compressed, and we believe this is a good compression algorithm. It doesn't really compress that good, obviously. It's the same data, the same amount of rows, the same information, but takes 3 times of your memory. That means you can load 3 times less data into your model, or you have to sooner scale up your hardware, your laptop or your machine or whatever. So this comes with a price attached. Of course, we have some space used for relationships in the star schema and Snowflake schema. This is because if you have relationships, Power BI and the Vertebrate engine stores the distinct values and how they are connected to each other in a separate space to speed up the joins. So it's like an index. If you're into relational databases, indexes also takes up space, but it's neglectable, as we can see here, like 84 megabyte, and this is around half a megabyte. And yeah, the Snowflake has a little bit more, 2 more relationships. Also, the relationship is space used is bigger here. So how can you transfer your model into a star schema? Use Power Query. Hopefully, you already use Power Query to filter your data, only filter down the columns and the rows you really need. Choose your friendly names. Don't have fact reseller sales as a name of a table. Choose appropriate data types and so on, and also flatten your dimensions. If you connect Power BI or Power Query to a relational database, it will even offer you to expand those tables where the table is connected to. So it's really easy to do in Power Query. Of course, you can also use it in DAX, but maybe then it's already too late because you already loaded the denormalized the normalized schema, and then you add up content again. And the best approach, of course, is if you have a data warehouse layer. This could be a relational database. This could be anything where you prepare already the model and then do all the hard stuff, the complicated stuff, to make it easy for the users to connect them to this model and don't have to use Power Query for that. And please do not flatten facts. So do not add attributes to the fact table, because that's the big table and we want to have it really, really slim as possible. So for the 15 minutes to go, and this is about the data dimension. The data dimension, I just picked the data dimension because I think it's really important, because I don't think I've worked with any model in my 30 years career where they were not related to any date or time. So the data dimension is really important. Yeah, link to the word arithmetic analyzer. Thank you very much. This is a really cool assistant. So the numbers I got here, like the size of the model and the relationships and so on, and I did with the Vertipack analyzer. So this Vertipack analyzer is more or less an Excel file, which you can then connect to your model, which then uses all those dynamic management views available from either Power BI or Analysis Services Tabula, and then shows it in a good readable and sortable way. You can also use DAX Studio. So the Vertipack analyzer is also built into DAX Studio, where you can also run those statistics over that. And then you can also find out not only what's the biggest tables, or how many tables you have, but what's the biggest table and what's the biggest column in the table. So if you're struggling with performance and or size of your model, it's easy then to find out what kind of columns you should think of, either to slim down the granularity. So maybe it's enough to store not everything by millisecond, but by second or minute or hour or day. This will then make your model slimmer. Or kick out those columns you're not sure that you really need. So the data dimension. And the data dimension itself, when, as already I told you, that I came from the database perspective. So I was used to normalize my databases. So I was not into BI from the very start. And then I saw the star scheme. I thought, oh my God, oh my God, this is not, you cannot do the sales territory and have the group of the territories in the same table. You have to normalize this. No. With the star schema we have to do, and there's really advantages. But I had to learn this also. And then also this idea of a data dimension. Why the heck would you have a date dimension? You can always use your SQL query and convert the date to the year, to the month, whatever you need. But the thing is convenience. I can do that. I'm fluent in SQL. I can do that, but maybe not all of my end users can do it, and or the tools they're using cannot offer handling those things, and or then we duplicate logic. So if you agree that we want to see the month name in the header and everybody uses different approaches, then somebody might put it in English, the other one in Danish or in German. Some might abbreviate it the month, some show only the numbers. So this is really this is not standardized. And for good reports, I would like to have the month always written in the same way. So we should push this to the data model. In SQL, you can do that. And you can do this by having a data dimension, because then a data dimension, there's a field called month, and everybody uses the month, and then everybody's report looks like the same. And if we agree on we want to change the month names, how they look like, then we only change it on one place in this dimension. All the reports will look the same again. That's one thing. And the other thing why you need the data dimension is for time intelligence. If you wanna or have to use the DAX functions for the time intelligence. So they need a data dimension in the case of having a full years. So starting at the 1st of January to the end of December for all the years you want to lose. And you should mark this as a date table. It's only necessary if your datetime key is not a date time, but something else like an integer or something. But I would go for always mark the date table as a date table, because then you'll find all the cases and don't have to think about complicated rules when to do it. It's no harm if you mark it, but it makes time intelligence functions work in the case you have a different datetime key. And Eric is also here. Hi, Eric. Also create DAX and double editor 3. Okay, I did not, I have double editor 3, but still didn't work too much with double editor 3, I have to admit. Sorry for Daniel. Hope he's not in the audience here. So, the auto date time. This is something we have to talk about because Power BI, as this is so important to have a data dimension, Power BI creates a data dimension for you automatically, which sounds like a good idea. And I tell you, it's not a good idea. Don't do that. We'll talk about that later. We can easily build up our own data dimension by using the calendar auto function or the calendar function, or that's, I think, the best approach, creating a data table in your data source in data flows, in your relational database, in Excel. So just build it there with tools you know by heart and build a nice date table having everything in there what you need, and then use this table instead of the auto date time. And then hope there's time for the role-playing and multiple tables approach, how we could model, for example, you have a sales table and then you have an order date and a ship date. So 2 dates in the same table. So how would we model that? So mark it's a date table. That's what you find in the modeling view, and mark something as a date table. Then you get this list of available columns of data type date, and then you choose the one, and that's it. And you should do that in all your models, and then you're always fine, even if it's not also necessary. I jump over this demo here for time reasons. So close the file here. Then the auto date time. That's the thing you should turn off, and there's 2 ways of turning it off. You can turn it off under options, so on the file, options and settings, and then on the options, and the current file in data load, there's this time intelligence section. You should turn this off. Don't create this data time. So make sure that the check mark is not checked, and you make sure that all the new files you create in Power BI also have this turned off. Make sure that you also in the global option, the global sections on the total load, you also turn it off. The reason why I'm urging you to turn this off is several. So one is that this feature will create behind your back. You can't see it in Power BI. You have to open up Vertipack Analyzer to see it, but you don't see it immediately. That Power BI is creating data tables for you, and as you can see, there's of various sizes. So what this feature does, it looks up like the smallest date in, like it looks up all your tables, all your columns, and per date column, it will create such a table. And the table is created in the sense of it looking up what's the smallest date in this column, what's the biggest date in this column, and that for the full years, so rounding down to 1st of January and rounding up to end of December, creating a date table there. Even if you not want to use the time intelligence on this table, it should just create it for you. That's the first thing. So your model size will increase. The second thing is you're limited to year, quarter, month, and day. If you think you don't need the quarter or the month name should like be in a different language or different layout, no chance to change it. So you stick to this. This is very unflexible. And the third thing, which the first 2 does not convince you, the third thing is that the logic how those year, month, and so on is referenced is a certain syntax in DAX. So if you use this auto date time in your reports, it uses certain syntax to reference the year and the month and the day, for example. So if you later decide, oh, this model is way too big, I have to turn off this auto date time, you turn this off, it breaks a report because the report done, because you introduce a new date table and the syntax previously was used doesn't work anymore. So again, this is a big mistake you can make in the beginning. And if you want to justify this mistake, it's really hard to do depending on how many reports you already built, or if you publish this, maybe you publish this model and other people also created reports on that, it's impossible to change this back. So 5 minutes left to speed up. And there's role playing. So maybe I skip the demo and just use my time to explain what I'm really doing here. So role playing would be one way of like having a sales table where we have the order date and the ship date. Now I jump over to the demo. I will make it this way. So maybe it's easier to explain here. So I have the date. I have a date table, and this is referencing only the order date. So there's only here we go. So there's the date, there's the sales, and we have 2 relationships. There's one active relationship between date and order date, and there's an inactive relationship between the date and the ship date. Why the heck is this inactive? Why is this not active? I cannot make this active because at one point in time, there can only be one active relationship between two tables, because otherwise it would be ambiguous. Because if I select something here, if I put a filter in here, should it filter the sales table on the order date, or on the ship date, or on both? So this is ambiguous. And Power BI does not allow to have ambiguous models. But what I can do is I can then use DAX to activate things. So this filter only works on the order date. So we can see this is limited to June of 2023. The ship date is in July. Still see my values here because the ship date is not filtered by this date here. But what I can do is that I can create a DAX measure, my ship date. I'm summing up my quantity from my sales table, and then use calculate to pass in a second parameter where I ask for, please, for the sake of this calculation, of this measure, ship quantity, not in the whole model, just for the sake of this one measure, please use the relationship between the ship date and the date. So then we see, like, I have different dates in here, and the ship quantity, which is this measure, shows up values only in July because everything was shipped in July and not in June. And I could then have my standard quantity, or what I would do is I also would create the order quantity where I do this user relationship on the order date again. So I have two different measures, and I could show also those two different measures in one single visual. So you can see when things were ordered and when they were sold. So this is one way of modeling this. The other way of modeling this, let's open up the other way, is having multiple tables. So having one order date table and one ship table. In multidimensional models, you could have like virtual tables where you just were referencing those dimensions. In Power BI, this is not possible. So we really have to load now two different tables. So the whole content of the table twice. Again, for the date table, that's not a huge amount of data we're talking about. And then we could have two different active relationships, the order date filtering the order date and the ship date filtering the ship date. So then we don't have to choose two different measures. We don't have more complicated DAX, but we have two different tables where we can filter from. So you can put one filter on the order date table, another filter on the ship date table, and then combine those things. So for example, I could ask for, please only show things until the 2nd. Then I will filter the order date. And here I could ask, please only show things from the 3rd. Then I could also filter the ship date here. With that kind of approach, I can also build a matrix like that where I can see then that things were ordered on this day and when were they shipped. This is not possible with the other modeling approach. On the other hand, with this approach, I cannot have, I only have one measure, the quantity, so I cannot show two different quantities sorted by order date or ship date or filtered by ship date or order date in one single visual. That's not possible then. With that, I jump back to my takeaways. 2 minutes to go. So please, 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 please take data modeling very serious. It's very important in Power BI to model your data and to get everything right here. Stay away from many-to-many cardinalities. Stay away from bidirectional filters. Prefer the star schema or only implement the star schema. I know sometimes it's hard. It's not easy to transfer a fully normalized schema into a star schema or any kind of model or Excel spreadsheet you get delivered. This is really hard to do, but spend your time there. It's worth. The performance is better. The DAX, writing DAX is much easier, much more convenient. There's a linked list there. And so I walked you through relationships, denormalizing, and date dimension. And yeah, visuals and DAX do like a shaped data model, and they don't like those ad hoc things you just put into Power BI, which is possible. And sometimes I also do this just quick and dirty, but before I hand it over to somebody else, I make sure everything is shaped and right. With that, back to Jens into the studio.
All right. Thank you very much, Markus. That was a brilliant presentation. I have seen your slides, and I hope you will share them and we can post them in the user group, because that checked off one of my questions on pointers to modeling, and I think you have those in the slide deck, so that's perfect. And maybe one final question is that how do you validate, or do you have any tips to steps you would perform in terms of validating your model?
In validating?
Yes.
What do you mean with validating? I mean, if I get handed over a model, I first look out for many-to-many relationships for bidirectional filters. If you think about that validating, if like is the quality good of the model or not, I would look out for that. And then most of that tackle many things already. And I would also look out for like very complicated models, like if there's really just one or several fact tables with dimension tables, or is it like really spaghetti code where you have lots of relationships between different things. And I have to admit, the very first Power BI report I produced and went into production, it was just a few. I mean, it was hundreds of rows, but the report was so slow. And the reason was that I had many and bidirectional filters there, because they asked me if I put a filter there, it should also change something here. I said, okay, I just put this in the model. And before it was too late, after it was too late to admit, I ended up with a model which was really poor in performance. So it's also a hard lesson I had to learn.
Okay.
And I hope you do a shortcut and don't have to learn it the hard way.
Yes. So as Eric pointed out in the chat, best practice analyzer in Tabular Editor is an option for validating the model as well.
Exactly. And I use this constantly. So this is really useful. It picks up a list of things you should improve, and all of them have a reason. So some of them sound really silly, like camel case or whatever, but it's really important to stick to those things. I'm not sure if is there a link out there that get you to a repository explaining why this is so important. Not sure about that, but every single bit this best practice analyzer points out is useful bit, and if you violate the best practices, you will pay a penalty later on. For sure.
Certainly. So one final question in the chat: do you prefer classic bridge tables over bidirectional relationships when setting up a many-to-many relationship?
As I grew up with normalized schemas, I use always the bridge table approach by default. I don't think it's in this slide deck. I have the other slide deck where I can do more advanced thing. There's a slide I can provide this slide also for you, which gives an overview. There's some edge cases where the many-to-many relationship indeed is better than the bridge table. So there is some certain use cases where, like, if it's really big models, then it might make a difference. But I came very far without any many-to-many relationships and always building the bridge table, because I have then control about I think I have better control about how the relationship is done instead of depending on what Power BI or analysis services does with this many-to-many information.
All right. Well, if that's the final words from you, I will stop the recording, and this will be made public